Because there are so many different organic molecules, there needs to be a way of naming them that is logical, makes sense to people. So the International Union of Pure and Applied Chemistry, IUPAC, has come up with a set of rules that will give each molecule a unique name. So if we see that name, we can draw a structure from it. Each IUPAC name has three features. They've got a parent name, and that represents the longest carbon chain in the molecule. The name ends with the ANE for alkanes, and that tells us about what type of molecule it is. So ANE tells us it's an alkane. And the third part is the names of side groups in the molecule. So that's the groups that come off the side of the carbon molecule. Now we've already talked about naming straight chain alkanes, so we need to know the prefixes, the words that go at the front of the name, which is dependent on the number of carbons in an atom. So one carbon, it's a prefix meth, and so on. So we have meth, eth for 2 carbons, prop for 3, bute for 4, pent for 5, hex for 6, hept for 7, and oct for 8. So we can go a little bit further than that. If you want to have a look at 9 carbons, that would be nonane, so non is the prefix there. 10 carbons, decane. 11 carbons in an alkane is undecane, and 12 carbons is dodecane, and so on, and it builds up from there. However, what we want to talk about is being able to name branched alkanes as well as straight chain alkanes. Now, when you have a side chain that contains carbon and hydrogen, these are called alkyl groups. So they have one less hydrogen than their corresponding alkane. So for example, you've got 1 carbon in a side chain, and it's a CH3 group, and its name would be methyl. Notice the name of the alkyl group ends in YL, so the side chain name ends in YL. So we had 1 carbon methyl, 2 carbons ethyl, 3 carbons propyl, 4 carbons butyl, and 5 carbons pentyl, just as we would expect with the prefixes for the alkanes. It's just the same. So when we have a look at something that's a bit more complex than a straight chain alkane, something like this structure here, we follow a set of steps. First step is to work out what the longest continuous carbon chain is. So if you can put your pen on one end of a chain and count along, oops, we don't want that there, 1, 2, 3, 4, 5 carbons along, 1, 2, 3, 4, and going down here, 5 carbons along, 1, 2, 3. So 5 carbons is our longest chain, and we can choose either to go around the corner or just to take the 5 along the top there. It's probably the easiest. So now we need to name that chain, and with 5 carbons in it, it's going to have pent as its prefix. It's an alkane, it's all carbons and hydrogens with all single bonds, so the name will end in ane. So we've got pentane as part of the name of the structure. Second step is to identify and name the groups attached to the chain. So if we take this group here and say it's our side chain, that's a CH3 chain, a side group rather, with 1 carbon and 3 hydrogens attached to it, and that will have a prefix of meth, and remember the side chain ends in YL, so it would be a methyl pentane. And methyl gets written in the front of this name. Third step is we want to number the parent chain starting at the end nearest the side group. So we're looking at the parent chain, we want to number it, and we want the side chain to have the lowest number possible. So in this case we're going to number from the left. So we got 1, 2, 3, 4, 5, and that helps us work out where the side chain is. So we identify in the name where each side group is. So because the side group's off the second carbon, 2 needs to be part of the name. So we go 2 hyphen methyl in front of the pentane. So the 2 is directly connected to the methyl to say the methyl group is off the second carbon. And you notice there's a hyphen between the number and the words. Then we put the name together with side chains in alphabetical order. If there's more than one, so ethyl would become before methyl. If we had two methyl groups, we would call it dimethyl, and we would have 2,2-dimethyl with commas between the numbers and that sort of thing. But we'll talk about that in a minute. So this structure here is 2-methylpentane. Let's have a look at this structure. So first of all, the parent chain. What's the longest chain? We could just go across the top, 1, 2, 3, 4, or we could go 1, 2, 3, 4 around the corner, or 1, 2, 3, 4, 5. So you can see here the largest chain actually goes around the corner, but that's a continuous chain still, so that is 5 carbons long. Again, that's a pentane group. That means instead of this is our side group, this bit here, the methyl group with 1 carbon in it, is our side group. So methyl is in the name as well. If we're going to number these, it wouldn't really matter whether we numbered from the left or from the bottom, because that carbon there is going to be number 3 either way, and that's going to give us the lowest number. 3 is going to be the lowest number possible for the side group to be attached to. So remember, we have to identify the position of the side groups. So we put this together. We want 3 to go next to methyl, and then pentane is the last part of the name. So shall we just check that answer? 3-methylpentane. Well done. A more complicated one. If we look at the parent chain here, we've got 1, 2, 3, 4, 5, 6, 7 in our longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep, 7 is the longest continuous chain there. So we have a side chain that is, a parent chain rather, that is going to be called heptane. Side groups, this time we've got 3 side groups, 1, 2, 3, and we've got 2 methyl groups, 2 with 1 carbon in it, and a side chain with 2 carbons in it, so that would be an ethyl group. So we've got ethyl and methyl. Now remember, they are written in alphabetical order, so we have ethyl first and then methyl. We're going to number our chain. This time, to give our side groups the lowest number possible, we're going to number from the right. So 1, 2, 3, 4. Our side chains have the numbers 2, 3 and 4 rather than 4, 5 or 6. Give them the lowest numbers possible. So we're going to identify the position of the side groups and the name now. So ethyl, the ethyl group is off the 4th carbon on the parent chain, and the methyl groups are off the 2nd and 3rd carbons. Now we could write 2-methyl, 3-methyl, but it's easier to go 2,3-dimethyl. So when we put the name together, we put a di in there because di represents 2, and so we end up with 4-ethyl, 2,3-dimethyl heptane.